Assalamu alaikum and good evening. In this video, I'm going to explain consumer choice and duality. In the previous video, I discussed Shepard's lemma and Roy's identity, and based on those two things, that is the Shepard's lemma and Roy's identity, I'm going to build upon this thing, that is the consumer choice and the duality. Let me start with the utility function. The utility maximization problem for the consumer is as follows, and that is maximize utility function subject to the budget constraint, and that is in real sense inequality, that the total expenditure on the consumption of various goods is either equal to or less than the consumer fixed money income, and the condition is that the quantities to be consumed by the consumer are greater than 0 or less or equal to 0. Now we assume that P, that is prices, or the vector of prices, is strictly positive. Prices are greater than 0, prices never 0 or never less than 0. Similarly, consumer has a fixed money income and that is also positive, and the consumption set is in positive n-dimensional Euclidean space. So the solution to equation number 1, which I just discussed, is given by x of Pm, and that is equal to the function Gp and m. Now we may note that this function or these functions depend upon the prices of all goods and income. These functions are called ordinary demand functions or Marshallian demand functions, and we also call them primal preference problem. If we substitute the optimal values of the decision variables x into the utility function, we then obtain the indirect utility function. For the utility maximization problem, this gives this function u is a v function of x1, x2 up to xn, and that is equal to v of x1, which is function of mp, x2 also function of mp, up to xn also function of mp, and that is equal to function of psilon as a function of money income and prices of various goods. This is equation number 2. The indirect utility function specifies utility as a function of prices of goods and income. So we can also write this as this function epsilon of money income m and price vectors p, and that is equal to maximize utility subject to budget constraint, and this is equation number 3. Given that the indirect utility function is homogeneous of degree 0 in prices of goods and income, it is often useful to write it in the following useful fashion, and we can get this function which is given by equation 4. So since this is homogeneous of degree 0, so we can write finally equation number 4 as q is equal to p divided by m. Since there are n goods, so p1 divided by m, p2 divided by m, up to pn divided by m, and finally we have this function as a function of quantity. We can obtain the utility function from the indirect utility function as follows, and this is the consumer minimization of expenditure. So we write this in this function. We can obtain the utility function from the cost function as follows. Max u subject to cost, which is dependent on utility and price, and that is either less than or equal to vector of prices p and times x for all p in positive n-dimensional Euclidean space. This is the expenditure cost minimization problem, The fundamental primal utility maximization problem is given by this function that I just discussed before, and dual to the utility maximization problem is the cost minimization problem. That is, dual to the utility maximization problem is the cost minimization problem. On one side we have the consumer maximize utility subject to the budget constraint. On the other hand, the consumer minimizes cost subject to utility, to given utility. And we write this problem in this equation given by 8. The solution to equation 8 gives the Higgs's demand function as a function of utility and prices of goods. The Higgs's demand functions are also known as compensatory demand functions or equations because they hold utility as constant. The solutions to the solution to the primal and dual problems coincide in the sense that x is a function of prices and money income, and the Higgs's demand function is a function of utility target, that is some constant utility, and prices of goods. So it means in the primal problem, in Marshallian demand function we have prices of goods and consumer money income, whereas in the compensatory demand function or the Higgs's demand functions we have utility target shown by U and prices of goods by P. So for the dual problem, the indirect objective function is this, which is given by M, that is equal to summation j varies from 1 to n pj hj, which is a function of U and P, and that is cost function of utility, some utility target, and prices of goods. This is called the cost or expenditure function, and it specifies cost or expenditure as function of prices and utility. We have also discussed this already in the previous video. We can also write this as follows: C as function of utility and prices. So the problem is to minimize the total cost or expenditure on goods, where goods are given by the vector x and prices of various goods is given by vector p, and that is Vx is equal to utility, that is there is some target utility which is fixed. Since the cost function or the expenditure function, which is based on utility and price, is equal to consumer fixed money income M, we can rearrange or invert it to obtain utility as a function of consumer money income, that is M, and prices vector denoted by P. This will give us another function epsilon as function of M and P, where M is consumer fixed money income and P is the price vector of various goods. Similarly, inversion of this function will give the cost function, which is function of utility and price. These relationships between the utility maximization and cost minimization problems are summarized in this figure. So here we combine utility maximization and cost minimization. Utility maximization is on the left hand side, and the function is maximize utility. The objective function is to maximize utility subject to budget constraint, and if we solve that, that gives us Marshallian demand functions. And if we substitute the solution or the optimal values of the x or the goods quantities in the utility function, then we get indirect utility function, which is function of fixed money income and price factor of various goods. On the right hand side, we have the consumer cost minimization problem, in which we minimize total cost on various goods subject to utility equal to some utility target, and solution of this problem give us compensated demand functions are the Higgs's demands. And if we substitute the optimal choice values of the Higgs's demand function in the in this function, then we get the cost function, and which is also known as the expenditure function. So this is a dual problem, and this cost function and the indirect utility function are the reverse of each other. We have also discussed Shepard's lemma in the previous video. Once again, I would like to throw some light on this, and it is like if indifference curves are convex to the origin, the cost minimizing point is unique, and then we have partial of the expenditure function with respect to price of the ith good is equal to hi function of u and p, and this gives us Higgsian demand function for the ith good, which is function of some utility target and prices of goods. So as I mentioned, this is a Higgsian demand function for the ith good. We have a number of demand curve or demand functions for various goods, because x is vector of goods that varies from 1 to n. And if we substitute the indirect utility function in the Higgsian demand function obtained via Shepard's lemma in equation 12, we get x in terms of m and p, and that gives us the Marshallian demand curve. And specifically, we have this function xi is a function of utility u and p, and that is equal to hi function of u and p, and finally we have this function xi as a function of m and p. After this, we will discuss the indirect utility function and the Higgsian demands. This is basically Marshallian demand function for ith good, and we have a number of functions like this depending upon the number of goods. Then we switch over to the indirect utility function and the Higgsian demands. So if we substitute the cost function in the Marshallian demands, we get the Higgsian demand functions xi equal to xi as function of m and p, and that is function of that is some function gi of m and p, and finally we have this we substitute this, we get that this function is depends upon the expenditure and this p, and that is equal to the Higgsian demand function, and finally we have this. Now we discuss Roy's identity. We have already discussed this in the previous video, but once again we can rewrite the Shepard's lemma in a different way. First we write the identity, this function is equal to u given by equation number 15, and then totally differentiate both sides of equation 15 with respect to pi holding u constant. We get the following function. So this is the partial of epsilon function with respect to income, and this is the partial of this function c function with respect to price of 1, and again this is the partial of this epsilon with respect to p1, and that's equal to 0. If you solve this, then the solution of equation 16 will be equal to 0. Rearranging, we get this partial of c of up divided by partial of pi is equal to minus this partial of epsilon as function of c as function of up and p divided by partial of pi whole divided by partial of epsilon as function of c function of up and p divided by partial of m, that is equal to function gi of m and p, where the last equality follows because we are evaluating the indirect utility function at income level m. Figure 2 on the next slide will make these relationship clear. So this is figure 2. Here we have cost function on the left hand side and we have indirect utility function on the this side. If we differentiate this function, we get Higgsian demand function, and if we differentiate this function with respect to p, we get Marshallian demand function, and these are basically substitution, Marshallian demand function and Hicksian demand function. And the cost function and the indirect utility function, they are basically inversion of each other. Figure 3 shows both utility maximization and cost minimization. If we have fixed income given by this budget line and we measure xi good along the horizontal axis and xj good along the vertical axis, and this m as function of price and quantity of x divided by P2 is the vertical intercept, and this is the horizontal intercept, and this is the given utility. So the consumer has this fixed money income and he or she would like to get this utility target. So then Z at point Z, this is both utility maximization and cost minimization. So all points on the indifference curve passing through X will be assigned the same level of money income as function of price of goods and quantity of X, and all points on higher indifference curve will be assigned a higher level. So this is a consumer choice and demand. I hope this is interesting and useful for our students. Kindly subscribe to the channel and don't forget to click on bell icon so that you can get regular notification about my other videos that will be uploaded for you soon. Thanks for watching. Kindly share various videos of this channel in various WhatsApp